Breaking news. Infection has been spreading to many people today. Let's go to the investigators so they can tell you more about this infection.
Here we are at this tragic situation, and where many of these people that had participated in this experiment are now infected by the pill that these scientists had gave them. Now everyone behind these cages are infected. We don't know how long officers can hold these gates closed, and we do not know how long these people will be infected. Many officers have informed that everyone stay at home. Nobody come out of their houses for any reason. And soon we will be informing you on how to protect yourself and know the difference between the zombie brain and the human brain, and how to protect yourself from being bitten. Back to you, Rebecca.
Thank you. Now we're gonna go and see what is the difference between the human brain and the zombie brain. First, let's investigate the human brain.
Our brain is the most complicated organ of our body. It has three major parts: the cerebellum, cerebrum, and brainstem, which is also known as the medulla. The cerebrum is the biggest part of the brain. It controls our senses, our imagination, and our thoughts. So, whatever we see, touch, taste, smell, think, or imagine is controlled by the cerebrum. The second major part is the cerebellum. It is known as the little brain. It controls our motion, balance, and our ability to learn new things. The third major part is the medulla. It is also known as the brain stem. It does a few things, which are called involuntary actions. It controls our digestion, heartbeat, and breathing. These things happen automatically in our body. We don't have to put any effort here. So now you know about the brain.
That was good, but we need more information. Here's some more.
Your brain, the most complex organ in your body, the seat of who we are, what we are, the container for our thoughts and our memories. In short, we are our brains. Our brains are built from many parts that perform different functions. Deep in the centre of the brain is the brainstem. This is the oldest part of the brain, and has also been called the reptilian brain. It controls many essential functions such as breathing and heart rate or blood pressure. It's whether we feel hungry or thirsty. It's also the seat of our most fundamental emotions: happiness or sadness, fear and love or hate. They all seem to reside in the brainstem. Sitting atop the brainstem is the thalamus. This is like an older version of our brain, which now acts as a gateway to the higher cortical regions. All sensory information from our bodies, whether it's sensations from the skin or a sense of touch, passes through the thalamus and is directed to the correct regions of the cortex for further processing. Surrounding the thalamus is a structure called the hippocampus. This is a crucial part of the brain. It's the seat of our spatial working memory. It lets us remember where we put those keys, or how to get back home from work or school. This region has even been shown to be bigger in London cabbies after doing the knowledge. The folded outer surface of the brain is called the cerebral cortex. Although it all looks the same, it's actually divided into different lobes that perform very different roles. The occipital lobe contains the visual cortex, and so is concerned mainly with vision. The parietal lobe is concerned with processing sensory information and integrating it with the visual information from the occipital lobe. The temporal lobe is the centre for memory and learning. It contains the hippocampus and a number of other regions that are required for us to recognise different objects, faces, sounds and environments. The frontal lobe is probably the most important part of the brain for defining us as who we are. It's where our higher emotions and personality reside, as well as language and social behaviour, lots of the things that we think of as being human. It's our decision-making centre and contains the motor cortex, which controls voluntary movement. So we really are our brain.
We are so grateful for that information. Now, people, please be safe and stay aware of these. One sec. I have just received information that scientists have, yes, captured a zombie and are now investigating. Let's go live to the situation.
So, how did it get to be this way? Well, It's my professional opinion that the large gaping bite mark on its shoulder might have something to do with it.
Thanks. I mean, what causes its behavioral abnormalities?
Well, we know all behaviors are rooted in the brain, so I'd expect that something's gone terribly wrong, probably in there.
Thanks again, Dr. Obvious. Let me be more specific. What changes in the brain would have to occur in order to cause this kind of behavior?
Well, let's see. The first thing I notice is how it moves. Stiff-legged, with long, lumbering steps, very slow and uncoordinated.
What? Look again at how it moves. Stiff legs, long stance. These aren't Parkinsonian movements. Parkinson's patients take short, shuffling steps. And the posture's all wrong. This looks to me like what happens when cerebellum's damaged. The cerebellum's a little cauliflower-shaped area in the back of your head. But don't let its size fool you. That little guy contains almost half of the neurons in the entire brain. Patients who suffer degeneration from this region, something called spinocerebellar ataxia, show a lack of coordination that results in stiff legs, wide stance, and a lumbering walk. My money's on the cerebellum.
Touché. Okay, so we've nailed its motor problems. Now what about that whole groaning, lack of talking thing?
You know, it sounds kind of like expressive aphasia, or Broca's aphasia, which makes producing words difficult. This is caused by damage to the inferior frontal gyrus, or possibly the anterior insula, both regions behind your temple on the left side of your head.
I think you're only half right. Zombies definitely can't communicate, that's for sure. But they don't seem to do a good job of understanding things either. Watch this. Hey, Walker, your father smelled of elderberries. See? No reaction. Either it's not a Monty Python fan, or it can't understand me. I'd say this is like spot-on fluent or Wernicke's aphasia. Damage to an area at the junction of two of the brain's lobes, temporal and parietal, typically on the left side of the brain, is the culprit. This area is physically connected to Broca's area that you mentioned by a massive bundle of neural fibers called the arcuate fasciculus.
So, basically it's a moot point to reason with the zombie, since they can't understand you, let alone talk back.
I mean, you could try, man, but I'm gonna stay on this side of the glass.
Thank you. That's been enough information for today. Please be aware and be safe. That is all.